All right, guys, so in this example here, we have a force acting on the tooth of a gear. We're given that this force is equal to 20 newtons, and we're also given a couple of angles from two imaginary axes, axis B and axis A. And we're looking to find the components of this force F, which is 20 newtons, broken down into components along B and along A. So the easiest way to go about this is to kind of create a parallelogram. And if you're having a hard time imagining how to make this a parallelogram, treat axis A as if it's infinite, and treat axis B similarly, like such. Now, the next thing you want to do is recognize that your force F is going to be a resultant force, and you want to figure out how you can close this parallelogram using axis B, axis A, and your resultant force. So it's going to be something like this. We're going to go along axis B, along axis A, and then we're going to close our parallelogram like so. Now I'm going to name this component here vector B, and this component here vector A. And of course, because it's a parallelogram, that means that this force here is also A, and this force here is also B, just by using superposition. Now you also know that because you have 60 degrees here, then this angle here should also be 60 degrees because it's an alternate interior angle. So 60 degrees there, and then likewise, this angle here should be 80 degrees. And now with these two angles, now you know you have two smaller triangles here. In each triangle has 180 degrees in it. Minus 80, minus 60, it leaves you with 40 degrees. So this angle here is 40 degrees, and this one here is also 40 degrees. Now the last thing I want to do is get the direction of forces A and B, and I know it's not required for this problem, but just for completeness, I'm going to add that in. So what I mean by that is force A pointing to the left or to the right? And just by visual inspection, it should be pretty obvious, but what I'm going to do is I'm going to go ahead and rotate this parallelogram and make it horizontal, as we know horizontal, and it'll look something like this. Of course, I exaggerated it a little bit, and this is going to be force A, B, and B. And then our resultant force, we know, is going to point something like that. So with that in mind, that requires that force A must point to the right, and that force B must point down. Otherwise, this wouldn't work. Had I drew these arrows in the opposite direction, like this, what would happen is that you'd see if A was to the left, and that B was actually upwards, like so, you'd see that you don't actually get the resultant force pointing in this direction to the bottom right, because you don't have any downwards forces if B is pointing up. So B has to be pointing down, which means A has to be pointing to the right. So now let's go ahead and mark this up on our parallelogram. So we have B pointing kind of in that downwards direction, and then we're going to have, and I guess you call it negative B axis, and then we're going to have A pointing to the right in the, I guess you could call, positive A axis. All right, so now the next thing I'm going to do is just transpose one of these triangles. So we'll have A, B looking something like that, and then we'll have our resultant force pointing something like this. And of course, we have this as side A, this here is side B, and then this here is side C, which equals 20 newtons. And then we have all of our angles here. So here we have 60 degrees, here we have 40 degrees, and then finally 80 degrees. So what we're dealing with here is we have one side and all three angles. So we can call this an angle, or side, angle, triangle. So only one side, and we have all of our angles. So what I'm going to do here is I'm actually going to apply the law of sines. Now, normally I do prefer to apply the law of cosines when we're dealing with this sort of problem with like a parallelogram, although you have to have two sides to use the law of cosines. If you only have one side or less, you have to use the law of sines. So what the law of sines says is that side A divided by the sine of the opposing angle A is equal to side B divided by the angle opposing B, and that's equal to side C divided by the sine of opposing angle C. And now what are the opposing angles? Well, if I were to draw a line going to the opposite angle of A, that would point to the 80 degrees. So I'm going to just mark this up and say that this here is A, and then this here is B, and the 40 degrees will be C. And those are all capital letters, so hopefully that clears things up a bit. So we're going to have side A divided by the sine of angle A, which we said is 80 degrees, and that's equal to side B, also another unknown, divided by sine of 60 degrees, and that's equal to C, which we have is 20 newtons, divided by the sine of C, which is 40 degrees. And now I do some cross multiplying, so 20 newtons times 20 sine of 60 degrees equals B times sine 40. Divide both sides by sine 40, and you'll have that B equals 26.946 newtons. And then likewise, you can cross multiply for A, and you'll have that A sine 40 equals 20 newtons times sine 80. And if you divide both sides by sine 40, you'll isolate that A equals 30.642 newtons.